Fenv, or floating point environment, contains macros and functions for interacting with the floating point part of a CPU. And first it defines macros for classifying exceptions. Okay, so now we have another kind of exception. Let's review what we have seen in this and other courses. First, we have a try-catch block in Java and C++ and other languages, which is only a concern for software. Okay, and then we have the hardware exception as part of a pipeline execution in the CPU, and the CPU determines it cannot handle the situation and needs help from the operating system. For instance, if the data is on the disk and not in memory, then the CPU cannot fetch it by itself. Instead, it gets a so-called page fault. And well, what happened? That can be implemented at starting with the so-called translation look-aside table fault, which is either handled by the CPU itself or by the operating system, but that's a different issue. But the important thing is that the pipeline discovers that it cannot handle the situation, then it asks for help from the operating system. Okay, another example of that is when we get a segmentation fault due to using an invalid pointer. Actually, the mechanism is exactly the same as when we need to fetch data from the disk. Namely, that the CPU cannot do anything with this address, which is null, or some invalid address, and then it asks the operating system. Another situation is the perf performance monitor counter has counted sufficiently, so it needs to note to tell the operating system where the program was. I mean, to sample the program counter. Okay, so now we come to a third kind of exception, and that's a math exception, namely, for instance, a divide by zero, or inexact, namely that the hardware needs to round the result because the result could not be represented exactly. That's very common and not, well, it can be a bigger concern, but it happens very often, depending on the program and input, etc. Invalid, the operands are invalid, so this exception tells that. For instance, if there is an instruction for doing a square root, which some CPUs have, and we give it a negative number. Okay, overflow, too big result, underflow, too small result. And then the question becomes, is the operating system involved in this? No. It's detected by the hardware when the instruction is being executed. And just a bit is set somewhere in the CPU, and we will see later functions to check which of these math exceptions occurred, if any. Okay, then there are also macros to decide how we should round calculations, floating point calculations. So that was what I discussed, but in a little bit more detail than on this slide.